Welcome back to Ask the Educator, a podcast for all professionals involved in medical device processing and sponsored by Healthmark Industries. The education team here at Healthmark has 280 years of combined experience in areas ranging from sterile processing, endoscopy, OR, biomed, to hospital and industry leadership. Our goal is to leverage our collective experience to answer one of your questions each episode, giving you the practical tips you need to succeed in the evolving world of device processing. My name is Kevin Anderson, clinical educator here at Healthmark, and I will be your host. Let's get started. Hey everyone, welcome back to Ask the Educator. This is Kevin Anderson, your host, and today we have another guest educator with us. This is Bernie Spencer. Bernie, thanks for joining me today on this episode. Really appreciate having you here with me today.
And thank you, Kevin. It's a pleasure to be here.
So Bernie is from a smallish, remote area in Michigan. He's also not on LinkedIn, so you may not know him from the social media circuit as much as I've been trying to encourage him to join it and get involved in that conversation. But just as a little background with Bernie, for those of you who don't know him, he has 25 years of manufacturing experience, but in the last 8, he has been a surgical reprocessing tech and also a surgical technologist in the operating room. And Bernie, if I'm not mistaken, you've been running the reprocessing side of things too at your facility. Is that right?
Yep, that's right, Kevin.
Excellent. So with that in mind, I know we wanted to touch on some things that you've been able to do in your facility. And today we're going to focus a little bit on endoscopes, but you had some very simple principles you wanted to share as well. I know we were talking about, and I thought they were really valuable, something that you brought from that manufacturing background that I think really applies to sterile processing.
Yes, absolutely. A lot of people, when I talk about my background and I tell them that I switched from automotive manufacturing to the healthcare field, they say, wow, that's really a change. But actually, both careers have a common goal in providing high quality outcomes. And during my manufacturing days, the company I worked for was promoting a book written by Dr. Edwards Deming, who was a quality systems guru. And what I really like about him is that his principles and concepts are so simple and direct, but yet brilliant. You probably heard the saying that the definition of genius is taking something very complicated and making it simple. And that certainly applies to Deming. So there are 2 of my favorite Deming principles that I'd like to share with you that guided me in manufacturing that fit very well in the medical field. And also, there's a concept that I was made aware of 30 years ago during a seminar that I'd like to share as well. So getting right into it, the first Deming principle, and I'm going to paraphrase a little bit here, is inspect what you expect. Again, inspect what you expect.
Yeah, I love that one.
Yeah. In manufacturing, we had machines that produced parts from raw materials. We supplied the big 3, so you have to be very quality conscious. In each job, there was a set of instructions on how to set up the machine. So if you set up the machine following all the instructions as written, you could expect the correct parts to be produced. However, you didn't just leave it at that. You had to inspect the parts using various measuring tools and visual inspection. In other words, you were expecting the machine to run the correct parts as a result of your correct setup, but then you had to inspect them to make sure you were obtaining the desired outcome. Does that sound familiar at all, Kevin, in the healthcare?
Yeah, absolutely it does. And I definitely am familiar with Deming and some of these principles you're talking about. And I couldn't agree more. These things absolutely apply to us in the medical device processing world. And I love that one. Inspect what you expect. So yeah, let's move on to the next one.
So the second Deming principle that I like goes like this. It's not enough to do your best. You must know what to do and then do your best. One more time, it's not enough to do your best. You must know what to do and then do your best. So using manufacturing again as an example, imagine that in order to produce a part according to the customer's specifications, you have to perform 10 specific steps in the setup. So if the machine operator is only performing 9 of those 10 steps, even if those 10 steps are performed perfectly, the desired outcome won't be achieved. So we could say that it's not enough to do your best performing only those 9 steps. You must know that there are 10 steps, and then you do your best at performing all 10. And then finally, the concept that came into my awareness some 30 years ago at a seminar, there's 3 parts to it. The first part is I know, and I know that I know. So suppose that I'm a master electrician. I could say that I know all about electricity, and I know all about electricity. I know about it, and I'm aware that I know about it. The second part goes like this. I don't know, and I know that I don't know. So again, using the electricity example again, let's say the only thing I know about electricity is that when I flip the switch, the light comes on. That's it. I don't know anything about electricity, and I know that I don't know anything about electricity. And then the third part is a little tricky, and it goes like this. I don't know, and I don't know that I don't know. And this is similar to the second Deming principle example that I gave, where only 9 of the 10 steps were performed in the process of setting up the machine. You could say that the operator didn't know there were 10 steps and didn't know that he or she didn't know that there were 10 steps. And this is where we get into trouble, Kevin. And that's why it's so important in our industry to attend conferences, webinars, listen to podcasts, read industry periodicals, and network with other people, things like that. When we learn what we didn't know and we didn't know that we didn't know it, it usually results in one of those aha moments. Oh, I didn't know that. And I didn't know that I didn't know that. Ever had that happen or observed that happen, Kevin?
Oh my gosh, so many times. I mean, I just as a very simple example, I was somebody who didn't necessarily believe, back in my OR days that certification was really a valuable thing to go and obtain after having obtained a degree in nursing and all that stuff. Well, lo and behold, I ended up studying and getting that certification. And throughout the course of that studying, I definitely realized the value in it because there was so much more in-depth material in the operating room certification that I had no idea. And it was very helpful for me to have a broader spectrum view of the department and of my role and a lot of the rationales behind what we do that you find in the standards that you're not going to find unless you're learning about them. So yeah, I can definitely relate to that. And hopefully our audience can as well.
Yeah, absolutely. And we get caught up in, and I'm sure you've heard this maybe once or twice, but this is the way we've always done things.
Oh gosh, yes.
We haven't had any problems. Well, the way we've always done things isn't necessarily a best practice. So we're always looking for new and innovative ways to do things that maybe is better than the old way that we did things.
Yeah, that's the hope for sure. I mean, you got to have that open mind. And one of the dangerous places to be, as you alluded to earlier, is that you don't know something, but you don't realize that you don't know it. That's about as bad a place you can be, and something that I think we all have to admit to being in a place like that at one time or another throughout our career. And when that light bulb goes off, then you realize, oh my gosh, I've been doing this incorrectly all this time, and I wonder if it put anybody at risk. And then you have to, live with that, and then hopefully build on that and continue to evolve and embrace that education going forward. But I know that you had ideas of how to apply these principles as well, specifically to the reprocessing of endoscopes. And I'd definitely like to touch on that as we go into this.
Perfect. Yeah, so how does my conversation so far apply to the medical field? I'll give you a very specific example, manually cleaning the instrument channel within a colonoscope or EGD. The manufacturer's instruction for reprocessing instructs to insert the brush into the suction valve port and down through the channel and out the distal end of the insertion tube. Then the brush is to be cleaned with gloved fingertips. Next, pull the brush back through and out of the channel. And at this point, the brush is visually inspected. And if there are any debris or discoloration present, we need to clean the brush and repeat the steps until there are no debris or discoloration present. This falls right in line with the first principle that I mentioned: inspect what you expect.
Mm-hmm.
You're expecting the brush to clean the channel, but you don't just make 2 passes with the brush and call it a day. You inspect the brush to determine if the channel has been thoroughly cleaned. Now, 4 or 5 years ago, I read some literature suggesting that even though the brush appears to be clean upon visual inspection, that the channel may not be clean to an acceptable degree. If you think about it, the inspection is an indirect inspection. Given the manufacturer's instructions, you're not visually inspecting the channel directly. You're inspecting the brush
Correct.
to determine if the channel has been adequately cleaned. And the literature that I read at that time also suggested that there were cleanliness tests that could be used to verify if the channel was adequately cleaned after brushing. So given that information, I had to know for myself. I thought that the cleanliness testing could be another way to inspect what I expect. I expected that channel would be adequately clean after following the IFU, but was it? Before reading the literature, I didn't know there were cleanliness tests, and I didn't know that these tests existed. So to reach the desired outcome of having that channel adequately cleaned, I was doing my best with what I knew what to do. So we purchased 2 different types of cleanliness tests. And just to be clear, these tests are meant to be performed after the scope has been completely manually cleaned, right at that point where you would put the scope in your AER or OP bath to soak. That's when you perform the test. The first test that one of the 2 tests that we purchased consists of a swab connected to a very long stem. And you insert the swab into the biopsy port, push it through the channel and out the distal end of the insertion tube, being careful not to let that swab touch anything when it comes out. You don't want to contaminate it artificially. Then you cut the swab off into a vial of reagent, put the cap on the vial, shake, and then observe the vial after 5 minutes. If there's anything within that vial that doesn't look like a reagent or a swab, the scope has to be completely reprocessed. It means that there was something present in that channel that wasn't removed through manually cleaning. And if the debris present in that vial or on the swab is a bluish green color, that means there was still residual protein left in the channel. That's what the reagent does. It turns anything that's protein into a bluish green color, makes it very visible. The second test that we purchased, what you do is you fit a small plastic Ziploc baggie over the distal end of the insertion tube, and then you inject 20 mLs of sterile water into the biopsy port. And that water is captured in that Ziploc bag. Take the bag off, the end of the insertion tube, and then dip a strip into the bag. On that strip, there are 3 different colored squares, one representing protein, one representing carbohydrates, and one representing blood. And if any of those substances is contained within that sterile water that was flushed through the channel, one or more of the squares will turn a different color, indicating that those soils were still present in the channel. We do 100% testing of our scopes after each patient procedure. And recently I did a study of over 800 scope cleanings after patient procedures using the swab test. And I had some pretty interesting findings that I'll get into in a minute. Currently, we're using the strip test method. As a result of doing this testing, we had some failures. In a few instances, we had to reprocess the scope 3 additional times to get a passing result. Now, mind you, there were no visible debris on the brush after each of those cleanings. So I could have assumed that channel was adequately cleaned and moved on, but these tests proved otherwise.
Can I just stop you for 1 second, Bernie? So all of these endoscopes that you tested, were they manual cleaned by yourself, or were there other staff involved as well?
Initially during the study, they were cleaned by myself for probably the first 300 or 400 studies that we did. And we tried various things. We tried different brushes. We tried different detergents, injected another cleaning person into the mix to see if there was a difference between how I cleaned versus the other person.
Excellent. So with that being said, I do want to let you get into your results. So I apologize for interrupting. But yeah, so 800 endoscopes tested. And then what did you find out?
One of the main things I found out, in my opinion, that visual inspection of the brush is not a good indicator of whether or not the channel's been adequately cleaned. At one point, and I think this is interesting, at one point during the swab test study, our scopes had anywhere from a 3% to a 10% failure rate on the test, except for one colonoscope. It had a 33% failure rate. We do periodic inspections with a borescope, and after seeing the results of that scope with the high failure rate, I looked inside the channel with that borescope and saw some damage. There was a gouge. So we sent the scope out and had that channel replaced, and after the repair, the scope didn't have another test failure until almost 40 patient procedures later. And over the long term, after the repair, its failure rate fell in line with other scopes. We had a similar situation with an EGD later in the study. Now, I'm not implying that scope damage is the only reason for a test failure, but in my opinion, has a significant influence.
Absolutely. I think what you uncovered is some pretty significant evidence that internal damage to our endoscopes does, in fact, impact the cleaning efficacy. And, if you're not testing or if you're not visually inspecting, then there are chances that you're missing some contaminated endoscopes in your process, which unfortunately would lead to an increased level of risk. So I think you uncovered some valuable information there. You found a scope that was getting more failures in your cleaning verification test than any other scope, which turned out to be a damaged endoscope. I mean, that's a pretty significant finding. And what else did you discover? I know you had a failure rate that you had found and calculated. These are things that I think are interesting that you know about your cleaning process that I wonder if our audience knows these things about their endoscopes and their cleaning procedures,
Mm-hmm. Yeah, and I even went as far as to our repair facility. I said, send me back everything that you replaced, because I wanted to see how that scope worked. I wanted to see that channel. I wanted to understand these scopes and how they worked. And it really, I'm fortunate where I work in that I'm in the OR, I'm in SPD, I'm a tech in the endoscopy room. I'm cleaning the scopes and turning them around. I like the variety. And, cleaning the scopes sometimes it's not the funnest thing in the world, but having these tests, it's kind of, you kind of get to see A, how you're doing, and B, how is your process. So it kind of really forced us to look at our process and how we were doing things. And over time, with not that we were doing anything wrong, but we're just more cognizant of our process and how it affected the outcomes. And over time, our failure rates went down, along with sending scopes for repairs and just really tightening up our process. So in conclusion, revisiting the principles and the concept that I mentioned earlier, now I have another way to inspect what I was expecting. In my experience, again, the cleaning brush in some instances was not adequately cleaning the channel. Not all scopes are contaminated equally during a patient procedure, and all debris are not adequately moved by just brushing. It's not enough to do your best. You must know what to do and then do your best. In my opinion, I now know what to do so that I can obtain a better outcome, a scope channel that's been cleaned to an acceptable level before high-level disinfection. And finally, I went from a position of not knowing if the channel was adequately cleaned after brushing to, after reading the literature, to knowing that it was adequately cleaned and knowing that I know that it has been adequately cleaned. There was testing available that I didn't know about, and I didn't know that I didn't know. It was only by reading information outside of our facility and keeping informed about current technology that let me improve our process, resulting in higher quality patient care.
Yeah, no, I think that's great. And, unfortunately, we're running short on time for this episode. But Bernie, I think you did a great job of, one, explaining these very important principles that do cross over from the manufacturing world, but help guide our thinking, right? And they help us to open our minds to, the value of education. So because we want to know what we don't know right now, and then be able to do our best at it. Because if we don't know what we don't know, that's where we're leaving ourselves and our patients vulnerable. I think you did a great job explaining the principles. I think you did a great job giving us a very practical example with those endoscopes. And I just challenge our audience right now to implement those principles in their practice. Inspect what you expect. Bernie, I just want to thank you one last time for coming on the show, and perhaps we'll have you again in the future, because I know that you do a lot of these types of little experiments in your department. So thank you again.
And thank you, Kevin, and thank you, HealthMark, for both of you for being crusaders out there and doing what you're doing and bringing this information out to people and making us aware of these things that we didn't know and we didn't know that we didn't know. So thank you all again, too.
All right, let's do a short recap of this episode. I spoke with Bernie Spencer, a surgical technologist and SPD technician, and he shared with us a few principles that he learned back in his automotive manufacturing days and how they apply in the device processing world. One principle that he spoke of that came from Edward Deming says to inspect what you expect. And Bernie applied this principle to endoscope brushing specifically. And he shared with us some things that he discovered, that even though brushing the endoscope channels appeared to be effective after visual inspection, it turned out that after using cleaning verification tools to check for cleanliness of the scope, it wasn't always adequately clean. So he then added this enhanced inspection step of cleaning verification to 800 endoscopes. So throughout that process, Bernie was able to identify endoscopes that needed repeated cleaning and endoscopes that needed repair. I'd say it was a good thing that Bernie decided to inspect what he was expecting from his endoscope cleaning procedure. I want to thank you all for listening, and I want to remind you to subscribe to our podcast so you don't miss out on any new episodes as they come out. Thanks again. All opinions expressed on this show are those of the presenters. Before using any medical device, it is important to review the device manufacturer's instructions for use.